All right, let's talk about a really pivotal moment in the history of databases. So, picture this. It's 2017. Postgres, it's already a total beast. I mean, it's proven, it's reliable, it's powerful. But technology was just racing forward, right? And Postgres was kind of starting to bump up against a ceiling, especially when you think about the modern demands for, massive scale and distribution. With pretty much any great piece of tech, there's that one moment, right? That one release that just changes the whole game forever. Well, for Postgres, that moment was absolutely version 10. And I'm not just talking about a simple update here. No. This was a complete, fundamental reinvention of what the database could be. So, here's what we're going to do. We're going to break down exactly how this one single version completely transformed PostgreSQL. First, we'll look at the scaling challenges it was up against. Then, we'll dive into how it totally reimagined replication. After that, how it made partitioning, well, simple. And then we'll get into the real-world impact of all this and how it really became a true distributed data platform. Okay, first up, the scaling challenge. Let's talk about the limits of PostgreSQL before version 10. Seriously, before this release, if you were a developer trying to really, and I mean really push the boundaries of scale with Postgres, you were going to run into some pretty major hurdles. And we're not talking about minor annoyances here. These were fundamental roadblocks. If you wanted to scale, you pretty much had to bolt on all these complex external tools. Replicating your data, it was this clumsy, all-or-nothing deal. And if you had a truly massive, ridiculously huge table, well, managing that thing was an absolute manual chore. So this brings us to the first huge breakthrough in version 10, a totally new, way more intelligent way to handle how data moves between servers. It's called logical replication. So think about it like this. Instead of just making a dumb block-for-block copy of your data, like a photocopy, logical replication is smart. It actually understands the meaning of what's changing. It sees an insert command, or an update, or a delete, and it sends just that specific change across the network. It's way more efficient. And this comparison here just says it all. The old way, physical replication, that was a sledgehammer. It just copied everything. But logical replication, that's a surgeon's scalpel. You go from copying giant data blocks to sending tiny, specific, row-level changes. You go from an all-or-nothing approach to being able to pick and choose which tables you want to replicate. And this is huge. You can even replicate data between different versions of Postgres. What a game changer. This just blew the doors wide open. All of a sudden, developers had this incredible fine-grained control. You could replicate just specific tables. You could do zero downtime upgrades across different versions. You could start building these really sophisticated multi-node architectures that were they were basically impossible or a total nightmare before. This was a massive, massive leap in flexibility. All right, let's talk about the second game changer, partitioning made simple. This tackled that other massive challenge, right? How do you manage these gigantic data sets without, tearing your hair out? Okay, so the old way of doing this, it really felt like a hack, didn't it? You had to build these clunky inheritance trees, write all these complex triggers and rules just to get the data to go to the right place. It was super complicated and, honestly, incredibly easy to mess up. Version 10 just swept all that complexity away and made partitioning a simple, powerful, first-class, native feature. And the new process was just beautiful. It became so simple. Step 1, you define your main partition table. Step 2, you declare how you want it broken up, maybe by month or by region, using really simple SQL. And step 3, well, that's it. You're done. PostgreSQL just automatically routes all the data to the correct partition behind the scenes. Something that used to take days of planning and coding was suddenly just a few lines of SQL. Incredible. And the benefits were immediate and huge. First off, query performance on these giant datasets got a massive boost because the database could just ignore all the partitions it didn't need to look at. And second, it made managing the lifecycle of your data way, way simpler. Need to get rid of old data? You just drop an old partition. Boom, gone, instantly. So much cleaner. Okay, so we've got these two amazing new features, right? Logical replication and native partitioning. But what does that actually mean? What did this allow developers to build out in the real world? Let's talk about the impact. Well, for starters, zero downtime upgrades became a real thing.
It was amazing. You could use logical replication to set up a brand new, upgraded server, stream all the live changes over from your old one, and then just flip the switch. Your users would never even notice a blip. No more late-night maintenance windows.
This also unlocked the world of real-time analytics. You could now stream every single change happening in your main production database directly into a totally separate analytics platform or a data warehouse. This meant you could get insights on what was happening right now, not what happened yesterday.
And, of course, it made building multi-region deployments so much easier. You could, for example, have a database in Europe that only subscribes to the data changes relevant to your European customers. This makes your applications way faster for those users and just so much more efficient.
So when you start putting all these new capabilities together, you start to realize something. PostgreSQL 10 wasn't just another update. It was a fundamental shift in the identity of the database itself.
And this quote really says it all. It wasn't just about storing data anymore. It was about moving it, scaling it, and controlling it with elegance. The database stopped being just this passive box where you dump information. It became an active, intelligent hub for your entire data infrastructure. And that right there is the key takeaway. Before version 10, PostgreSQL was an amazing, reliable database. After version 10, it became a true distributed data platform. You could almost think of it as becoming the central nervous system for moving and managing data at a massive scale.
And I want to leave you with this last thought, this powerful idea. Replication isn't just backup, it's architecture. Before version 10, a lot of us just thought of replication as, well, making a backup copy, right? A safety net. But what this release really proved, and what we all live with today, is that when you do replication with this kind of elegance and flexibility, it stops being just a backup. It becomes a core architectural tool for building the incredible, scalable, distributed systems that power our world.